Awesome. Hello, this is your host, Nalati. Welcome to the first Offers Hour session of the ZK Fellowship. A couple of weeks ago, we had announced a bounty to analyze the security of Suma's proof of solvency protocol. And the Suma team had reviewed these reports, and now they're here to share their thoughts and the winning submissions as well. So I invite Enrico to express his thoughts on the bounty submissions. Yeah, over to you, Enrico.
Okay, yeah, thank you, Naliti, for the introduction. So first of all, like for the winning, I will actually leave it to you because I share my feedback, but I'm
Mm-hmm.
not sure which one you decided was the winner. So I will just share my impression on the submissions that I think is more important than announcing the winner. So like the first thing that I noticed is that many of you misinterpret what was like the task of the bounty. So maybe it was like written not it wasn't clear from like the write-up what was the task. So maybe it was like our fault as well. But the task wasn't like to assess Summa solvency security, because I mean this is like a bigger task, and this is the the subject of the audit itself. Like the specific task of the bounty was the broken Merkle sum tree. So it wasn't like anything else, like range check, like many of you like kind of explain like everything, but that wasn't like the task. So the main task was like understanding first why like the paper mentioned this broken Merkle sum tree, why they think it's broken, then how Summa is like implementing this broken version of the Merkle sum tree, and then assessing the security of this. So the first thing was like task itself, that most of you didn't focus enough on the actual task and were more generic. And the second thing, even for those that actually uh, understood the task, so they were like kind of focused on the broken Merkle sum tree. I think you did a good job in explaining how Summa is secure from this broken Merkle sum tree. But that was like, I mean, it was like similar to the level of security that we assessed internally. So we didn't really, well, I mean, like from our internal analysis, it seems secure, but like from you as a auditors, as like security engineers, what uh what it would be cool to have is like more insights on how it is secure. So, for example, one idea would be like trying to attack Summa implementation in any way possible. For example, in the way that was described in the paper, and then explain why like Summa is not subject to this attack. So if you can find a bug, is even better. But like even if you cannot find a bug, I would like this report to have like the list of attacks that you tried and you failed. And a very good way to describe these attacks will be really to, for example, now you're familiar with ELO2, or at least with the Plonkish arithmetization and this concept of like table, witness, constraint. So it would be cool to have an illustration of the table, of the witness table, the constraints that are enforced in Summa, and then while passing a witness that would be causing an attack, which constraint will fail. So in the case of the broken Merkle sum tree, you could understand the attack described in the paper, then try to generate a proof using the witness based on this attack, and then tell me, okay, this constraint will fail because of that. So I think that would be like like the perfect approach. So that would be like the perfect review for such an attack. But this apply also for, I mean, I guess that this should be also be your approach to security from now on. So that was like just an intro. I think I don't know if you have any question. Otherwise, any question about this? Otherwise, I guess that the office hours is just, I don't know, open mic, and any question that you have, I'll try to answer, right?
That
Enrico,
is, yeah. Go ahead, Ali. Yeah.
Enrico, if you want, we could let fellows take another crack at it, giving your feedback, and say give another week or 2 weeks if they want to, uh, as you said, do some methodical simulated attacks and add something to a report that they did already, or if they haven't done it before, they can try it again. So if you want, we can do that.
Okay, yeah. It might be a good thing. We can also probably rewrite the task a bit. Maybe like this time we can try, because maybe also something that was, well, so first of all, most of the people weren't yet familiar with Halo 2 when we submitted the task, so that might be also well, maybe it was
Exactly.
a problem. So yeah, we can rewrite the task and yeah, resubmit the bounty.
Yeah, no problem. I think that would be a good idea, especially that fellows starting today, they're going to be working in groups, so
Okay,
they may find a way to work together, the whole group or as pairs. That plus the fact, as you said, that they are more familiar now with the code base. So, okay, we'll do that.
great.
Awesome. So thank you, Enrico. I think the fellows would now have a clear understanding of the bounty and what they're supposed to do. So moving on, we are here at the office hours with the fellows, the SUMA team, and the residents are here as well. So everyone is welcome to share your screen, or I could share it on your behalf. And you can ask questions, and be sure to use the Zoom chat box to put your questions, or you could just raise your hand. The questions may be about anything. It could be Halo 2 or the Suma circuits or the bounty or ZK security. Yeah.
I'll start with maybe just a generic question. Enrico, are you familiar with Halo 2 lib from Axiom?
Yes.
Is it ported into the PSE code base, or?
So actually not. So is like Axiom uses as their own fork of Halo 2 PSC. So basically is the fork of a fork from the Zcash
Yeah.
original implementation. And but I think when you use Halo 2 lib, there's you can set the feature, and it both supports the Axiom Halo 2 fork and the PSC Halo 2 fork. But I only use that with the Axiom Halo 2 fork. So I'm not 100% sure if they still support the PSC fork in the backend. So, but for anyone that might not know, like Halo 2 lib is a sort of abstraction on top of Halo 2 built by Axiom team, and what it allows you to do is basically when you have to set constraints, you don't need to write the table, like the assignment, the polynomial constraint manually, but you just call an API. So I can share here maybe some documentation, because actually it's simpler of course, than vanilla Elo2, but I guess that understanding vanilla Elo2 is required to use Elo2 lib anyway.
Yeah, I'm just asking because we might have a speaker talking about it, so I was just wondering about its relevance. Sorry, this was a lazy question. I could have looked it up, but thank you, Enrico, for adding some color to it.
Yeah, I have a question as well. It's about the trusted setup of summer solvency. So, the trusted setup is obviously not in the scope, but we would obviously like to know about the process and have you tried doing the trusted setup? And we just had a look at Halo 2 KZG SRS repository, and there were some outdated packages. So, yeah, I would like to know about the trusted setup and report, just specific to summer solvency.
Yes, good question. So, like the simple answer is that since we're not in production and we didn't have like requirements to build something that goes into production,
Mm-hmm.
from the trusted setup point of view, we didn't focus too much on that. So what we are doing right now is like as you said, nullity, like we are using this repository that is like Halo2 SRS, and what is this repository doing is they are taking like the some existing trusted setups. So specifically, we're using the one run by Hermes a few years ago, and the role of this repository is taking like the source file of the resulting trusted setup, and
Mm-hmm.
porting it into a form that is kind of can be consumed inside inside of Halo2. So we didn't assess the security of the repository. Like it was suggested by Anne, which is a colleague of ours, and
Mm-hmm.
I think it was also meant to be used by the ZK EVM of the PSC team. But again, even the ZK EVM is not production yet. So yeah, I'm not sure honestly how what is like the security of this library. So it may be something worth exploring more. But in general, outside of this context, also something that I wanted to mention for like to say again
Mm-hmm.
if needed is that, well, like for a good thing of Elo2 and the Plonk is that it doesn't require a circuit-specific trusted setup. So we can take an existing trusted setup and uh, and run it for our specific application. So in general, the risk that we are discussing, me and you, Naleti, is
Mm-hmm.
not about the trusted setup itself, but about the parsing of the trusted setup from an existing trusted setup to something that we consume in Elo2, right?
Got it. Yep. Yep.
Yeah.
So in summer solvency, who does the trusted setup? Is it the custodian? I guess yes.
Yes.
Yeah.
Yes. Well, I mean, like there's really no, I mean, if we use an existing trusted setup, it's not really like someone that is doing the trusted setup in the way that they are adding randomness. This part is already done. If we kind of trust the implementation run by Hermes, so there's also like this KZG ceremony that was run recently. So the part of doing the trusted setup is done. If you are asking like who's like let's say calling the function to generate the keys from the trusted setup, it can be either the custodian or ourselves, but yeah, more likely is the custodian.
But that
Right.
wouldn't involve that wouldn't insert any new type of trust assumptions because it's more of a janitorial step, basically.
Mhm.
Yeah. It's basically
Yeah.
they clone our repository and they run the script to starting from an existing trusted setup to extract all the artifacts that are needed for proof generation and proof verification.
Right. Got it. And another hunch I had was about the loose ends of this project. So in summer solvency, there's a lot of this guy does this and this does this. There's no, I would say it's slightly complicated pipeline. So I think the proof of inclusion is like verified off-chain. I'm not wrong. So tell us more about it. How does that happen? Or typically, when an exchange does this, um, what would be the process, or what do you think would be the security issues there?
Okay, right. So like the ideal scenario is that everything is done by the custodian. I mean, like the let's say the configuration of the system is run by the custodian. So they are the ones, as we said, generating the artifacts starting from an existing trusted setup. Then they are the ones deploying the contract on chain, the Summa contract, and the verifier contract. And they are the ones that are like generating the proof and giving this proof either for on-chain verification. Sorry, they will like generating the commitment for on-chain verification, the proof of address ownership for on-chain verification, and the proof of inclusion, which is generated to the user for off-chain verification, which even if it's an off-chain verification, can still be done through a smart contract interface. So this is might be something confusing, but this is not important. It's just for user experience. So think that this proof of inclusion is verified off-chain, but we provide this interface for the user to verify using a view function of the smart contract because it's just simple for the user point of view, and it's not like a front end that will kind of hide all the verification logic, but it's also not like a process that require the user to use the terminal or clone repository. So it's kind of a trade-off for user experience. But since it's a view function, there's no gas involved, there's no modification of the Ethereum state. So this might be something that is confusing, but think about it as being off-chain, and it's also not mandatory to do that through the smart contract interface. You can do in other ways. And related to the security, so the security issue, I think the thing that comes to my mind is that the custodian is not basically doing things properly. So uh, they are supposed to deploy a verifier contract based on the MST inclusion circuit, but they don't. So they kind of modify the circuit and I don't know, they create a circuit that is always returning true, and this would be like an issue. Or they are not, rather than using the Hermes trusted setup, they are just creating a setup on their own and then using this trusted setup to deploy the verifier. So there are like of course there are like ways to not to prevent that, but to assess that this wasn't done correctly. And I think is also mentioned in the documentation of Summa, but what we provide is let me link it to you. There's like this script inside Summa Solvency is actually inside example, and okay, it's here. I linked it in the chat. So this script is the one that we use for testing, for generating these artifacts. And this is the one that is supposed to be used by the custodian in production. And this can be also used by anyone else that wants to check that if they did things properly. So what you will do as a user that wants to, or also like just as a security auditor probably, that wants to check if a custodian is doing things properly, is that you take this script, you need to modify like levels, number of currency, and number of bytes according to what the custodian is claiming to be using. So this must be public information, and I mean, there's really nothing bad in making this public, but it's the custodian that must be doing that. Then the custodian must also tell publicly which trusted setup they are using. So in this case, you need to put this trusted setup at line 25. And what you will get in return would be a solidity verifier. And you basically need to check if the solidity verifier that you got is matching the one that is being deployed by the custodian. And if this is not the case, it means that they kind of did something wrong. And also, last thing, interesting, if you see on line 18, there's the assertion that is saying there is a risk of balance overflow in the merchant root, given the combination of number of bytes and level. So this is what I was alluding to some sessions ago, that oh yeah, thank you for sharing, actually.
Yep.
Sharing screen is like inside examples folder.
Examples.
Yeah, you have it on your right. Yeah. Yes, exactly. So line 18, there's like this assertion. So as we said in the previous session, like the risk of overflow might incur given like the number of levels and the number of bytes that we set as maximum. So there might be cases in which we range checked all the inputs, but like there are like so many levels and the number of bytes is so big that when you're performing all the summation, there's a risk that the resulting summation in the Merkle root is overflowing the prime of the circuit. And this is where we assessed it. So this is not, this is important, like this is not a constraint. It's just saying that if a custodian has been generating a verifier using this combination of bytes and level, there's a risk of overflow. So it's not secure. You should not trust this, basically.
Oh, so if I understand correctly,
Okay, let me give you an example. Like let's say that you have like a Merkle tree of 2 levels. So
okay.
there are only like 4 elements inside this tree, and n bytes is set to let me think. Well, let's make it even simpler. Like we said, like that the maximum. Let me think. Mm, mm, mm. Um, mm. Okay, let's make it simpler, like without using n bytes, but we'll get to there later. Let's say that we range check each element to be 4 at max. Okay, value of the balance must be 4. And so let's say I'm writing in the chat.
Or do you want to maybe use the notes feature? You would have it right here, right? The whiteboard.
Yeah, but I don't have it right now with me.
Okay, no issues. Yeah.
Okay, so we constrain that each balance must be less than 5 as a value, as a nominal
Okay.
value.
Mm-hmm.
And we have like levels equals 2. So there are like 4 leaves. And P of the circuit, so this is like the prime of the circuit, equals to 15. Okay.
All right.
So in this case, you see that like the balances will pass the check. So if we create like a tree that is like this, they will pass the check because they are like inside this constraint that they must be less than 5.
All right.
But if you add them together, like root will have balance of 16, which
Right. Which is
mod
greater than 15. Yeah.
yeah, which will be equal to 1. So in this case, there's an overflow, or at least there's a risk of overflow because of the combination the custodian choose of n bytes and levels. But the proof of inclusion in this case won't spot the overflow because for efficiency reason we are like just performing a rain check on the inputs, so on the lifts and on the elements, on the path elements. So that's the reason why you can still incur in an overflow, even if this is not spotted by the proof of inclusion.
Oh, this is like a risk. It's like a major risk. Like this function over here just checks if for a given combination of bytes and levels, if we have a risk of balance overflow. That's great. But yeah, this could be an issue.
Yes, yes. There's I think if you look through the documentation, um, there's like a better explanation of this whole thing.
Got it. So to just sum it up, this file, what it does is it verifies if the verifier contracts have been generated uh, correctly for the Merkle inclusion proof. Is that right?
Yes, I mean you can use it for 2 ways. Like you can use it to actually generate the verifier, and then it can be used also by a third party to assess that this was generated correctly.
Got it. Got it.
Like let's say I'm a custodian and I want to generate a verifier with this risk of overflow. I will just take this file, comment out line 18, and I will still be able to generate the verifier, right?
Right.
I mean, it's a warning, but a malicious custodian can just ignore the warning and still produce the verifier. But for a third party that is like auditing, is this was generated correctly? Yeah, this warning should tell, do not trust this verifier.
Right. Yeah. Awesome. This is like really insightful. Because for a project like Suma, when you look at it, it might be a little confusing when you have a lot of loose ends, but this really is helpful. Yeah, fellows, do you have any questions? Okay, we have one. It's from 0x Nerlin. He says, so for example, if the custodian removes the broken Merkle sum checks in the ZK proof generation, does that mean the verifier contract will change? Enrico, would you like to answer this?
Yes. Okay, so let's clarify like the terminology here.
Yep.
So I wouldn't call it like the broken Merkle sum check, because like this broken Merkle sum tree is something different. So this is, let's say, just like a we can call it like a combination that leads to a risk of overflow check. Maybe it's not like the most succinct way of calling it, but this doesn't have to do with the broken Merkle sum tree. So this is first thing. Also, second thing, that this is not part of ZK proof generation. So what we are doing here is we have the circuit. Okay, so the circuit has been designed as we wrote all the constraints, all the relation. So we just have like the skeleton of the circuit, and now we generate a verifier. So this is a contract that will be able to verify proofs based on this circuit. So right now we only have the skeleton of the circuit, but we don't have any proof yet. So like the proof requires like dynamic inputs, it requires like witnesses. So this is done before. We separate two phases. Like one phase is called key generation, and the second phase is called proof generation. So at key generation, you only have the skeleton of the circuit, and what you do is you generate like the keys. You can call them proving key and verification key, and these are function of the trusted setup and the circuit itself, the skeleton of the circuit again. And that's, you can see this in line 21. We use like this function init empty, which is basically like filling up the circuit with like zeros, with like empty values, because at this moment we don't know the proof and the witness yet. So this is not proof generation phase, but this is like a key generation phase. And to actually answer your question now, does that mean that the verifier contract will change? So the answer is no. If you remove line 18, the contract will not change. Like this is just an assertion, like a Rust assertion. It doesn't have anything to do with Halo 2, with like smart contracts, etc. So this is just really like a warning that we wrote ourselves. And you can think there are like probably other ways to handle this error. And yeah, it might be interesting to, if you have also other ideas of handling this error. Like one easy way to handle this error will be like to add more constraints inside the circuit. So we will keep assessing, like keep constraining each balance if is inside this range. So that would be also a solution, but we don't want to do that because in that way we'll be adding constraints to the circuit. That adding constraints to the circuit is expensive. It increases the proof time. So like the rule of thumb is that everything that can be verified outside of the circuit should be verified outside of the circuit. So that's the reason why we did that. We could write constraints for everything, but if there's something that can be verified simply outside of the circuit, that's what we choose for.
Right. That is a really good point. So if I can rephrase this question a bit, um, I think Nerlin meant to ask that if we remove the broken Merkle sum checks either in the circuit, I think he means that, does the verifier contract change?
Okay, yeah, sorry, I
But this
completely
is your answer was really good. Yeah.
yeah. Okay, yeah, thanks, Naliti, for clarifying. Yes, if that's the question, then yeah, basically I turned your question into what I wanted you to make. Well, anyway, like based on this question, yes, of course. So if you touch the circuit, so if you modify a constraint, the the key will be different. So the if you modify the skeleton of the circuit, this will result in a different verification key. But let's also imagine a different scenario. So the custodian generates the verifier properly. So in this phase, the circuit that you pass is the circuit with the right skeleton, okay, with the right constraint, including the broken Merkle sum check. But then at proof generation, they will take the code of the circuit and I don't know, remove this constraint. In that case, still the proof won't be verified because the prover will use a proving key that was generated for a different circuit, because as soon as you modify the constraint, remove, add constraint, this is a different circuit, so it won't be compatible in a way. So the proof won't verify anyway.
Right. To phrase it in a different way, to generate a verifier contract, you would need a verification key, which is generated when you do the trusted setup. That is, if you look at this line, it'd be much more clear. So yeah, the comments help a lot. So if the custodian changes the circuit, and there will be a different verifier contract. So the proofs generated using the original circuit, the proofs won't satisfy this contract. So yeah, there will be a mishap there.
Exactly.
Enrico, are there any other assumptions for things outside of circuits, for checks that are done in the input? Yeah, things like they chose not to constrain, as you said, for efficiency reasons.
Yes, that's a good question. Let me think. So Naliti, can you go inside the source and then circuits Merkle sum tree? Okay, and can you scroll down a bit? Yeah, instances here. Okay, so yeah, line 54. Being what are like the public inputs of the circuit. So the public input of the circuit are the leaf hash, the root hash, and the root balances. So just to put it inside the context, now we're using this circuit to generate a proof of inclusion for a user. And the leaf hash will be like the leaf corresponding to the user we're generating the proof for. And the root hash is the hash of included in the root of the Merkle-Sum tree that was committed to before, and the balances are the balances included in the root of the Merkle-Sum tree committed to before. So these are stuff that are public inputs, and these are verified outside of the proof. So let me give you an example. Like I can, let's say I'm Enrico, okay? I receive the proof of inclusion for user nullity. Like the proof will probably verify, but when I check the leaf hash, I can see that it doesn't match my combination of username and balance. So this is a check that is performed outside of the circuit. Or something else is like, let's say that the custodian commits to a Merkle-Sum tree with root balances 500. Then I get a proof of inclusion that the leaf hash is matching my username and balance. But the balances are just different. So they're like, I don't know, the root balance is like 400. So this is also something that must be verified outside of the simple, outside of the proof. So you need to perform check on the public inputs. And these are done inside in the verification function that is written in the smart contracts. So if you can nullity go inside contracts, no, outside, yeah. Contracts, source, summa, scroll down a bit, down. Verify inclusion proof. Okay, so you see that there are like these two requirements from like, yes, 98 to 207. Yeah, basically like this portion of code. Like these are actually verifying that these inputs, these public inputs, are matching the tree committed by the custodian before generating the inclusion proof. And the other public inputs, which is the leaf hash, cannot be verified by the smart contract because they just don't know what is like your username balance. So I mean, we could probably also have a function like here, like taking username and balance as input and doing the hash inside this function and checking if it's matching the leaf hash. But we don't do that for a reason that is, we don't want user to pass their data to a node that is running this view function. So it's just for like privacy reason. But these are the free checks that needs to be done on the public inputs of the circuit.
Right. So the three checks are you have to check if the leaf hash is matching the proper user balance, the hash of the user balance, and if we have the correct Merkle sum tree root, and what is the third one, Enrico?
The balance, root balance.
Oh, the root balance. So we should check the root hash and the root balance. So those
Yes,
are like
yes,
the three checks. Right.
exactly. Like the first one, it should say MST root hash, like line 198.
Mhm.
Like the name of the variable is probably a bit misleading.
Yeah.
And
So
the other one
this
should be
checks the root hash and this checks the root balances.
yes.
And we don't check the user balances, which is what um, we couldn't check the root balances because if you're checking it, the users would pass their private data and this could be misused. Is that the issue then?
Yes, and last thing, if you can go inside the into another file, so backend
Backend
examples.
examples.
Yeah, this one.
Yeah.
Scroll to the very last row. So you see that verifying commitment. Get Marcus on tree root. Okay, you see like line 109. You see that the user is basically extracting the leaf hash from the public inputs, and then they are like starting from their username and the balance. They're like building the leaf hash that they should expect, and they're checking if this is equal to the public inputs.
Right.
So the leaf hash should be equal to username and
And the balances.
comma balances.
Yeah, yeah. What could go wrong here, Enrico? Just from your developer point of view.
So what could go wrong? Like if you see that your balance is less than your actual balance, this is a big red flag. Like it means that you were included with understated balance, which mean that the liabilities that the custodian is claiming to have are actually understated. So that's the biggest risk.
Great. I think we've had a look at the trusted setup, the verification contracts, the verifier contracts, and the checks which we do outside of the circuit. I don't know if do we have any other questions regarding the circuits or the chips? Great. I think one of the residents had a question on, or maybe a doubt on the CSV parser, but I don't know where that file is.
So it's a ZK prover
Okay,
inside the ZK prover folder.
ZK Prover.
And then you need to go inside source,
Okay,
then Mercosum tree. No. Inside the Mercosum tree folder. And try utils.
oh yeah. So what do we do here basically? As the
Okay.
name suggests, I think we parse each of the CSV's entries to circuit readable data. Is that right? Or
Yes, that's true. Like yeah, basically like we have this CSV file with a like a standard format. So it should be, yeah, it's like yeah, CSV. Yeah, which one? Yeah, whatever you want. Yeah, this is like the format that we enforce. So it's like username, and then like you see that like balance should have this two, let's say, suffix. So it, like the first one, like balance it means it as a cryptocurrency and it as a blockchain.
network? Yeah.
Yeah, network. And USDT means USDT as a coin and ETH as a network. So yeah, I mean, there's really nothing crazy in this, but we need that because when we commit to the signatures on chain. So this is in the proof of address ownership phase. We need to tell, okay, this is an address that is living on I don't know, on a Bitcoin or on Solana, and then you can verify this against the balances that I have on Solana for whatever coin. So, and yeah, exactly. That's the let's say the complementary CSV file that we need. So this is like a CSV file this is the one used to generate the proof of address ownership, and this is saying like, yeah, I have like this address on this chain, and I'm signing a message, and this is the signature.
And then these signatures are verified on-chain.
It's submitted on chain, not verified.
Oh, right. It's just submitted optimistically and
Exactly.
we don't verify it on-chain. Got it.
Like all this data
Mhm.
that you see are submitted on chain, so like the verification can be done by off chain by anyone.
Great. Is there any security issue while using CSVs or while parsing CSVs or using these values? Could you think of any?
Okay, so I know honestly because
Mhm.
like the thing that we are using CSV file is totally optional. I mean, like the data, the important part is like when the data are inside the circuit. So that's when some security might incur. But like you can use if you go inside the um I think go inside the Merkle Sum tree folder and yeah, mst.rs file. You see if you scroll down a bit that we have yeah, we have like from line 74 is from CSV, but if you go down a bit more, down, there's also from entries. Yeah, it was like no, a bit up. Yeah, this function from entries. So 103. Like you can be this Merkle sum tree either starting from the CSV file or you can parse your entries in another way. You can implement your own parser. So the CSV file is just a helper function that we use, but this is not mandatory. And I don't think there's any security risk because this is outside of the whole circuit logic. And last thing that I wanted to mention is that if you go back to the CSV file, so this is actually important. You can make a case that the username is you can brute force the leaf hash and discover what is like the username and the balance of a user. So let's say that you have access to a username. Sorry, let's say you have access to a leaf hash. You can, I don't know, brute force every combination of possible usernames and possible balances and discover what is actually the username, the balance. So you have to think that the username doesn't need to be specifically like Alice or Bob. You can add some, you remember like I mentioned the salt, like
Yeah.
some session ago, you can add like Alice and some salt, which is like some randomness. So if this randomness is big enough, so for example, is like in a 254, 256 bits range, this makes the leaf hash almost impossible to brute force. So when we say username in this column, there's really no enforcement on you should pass Alice, you should pass Alice plus salt, you should pass an email, you should pass whatever you want. So this is also a point that I wanted to make. This is not like security in terms of in terms of mm, generating a wrong proof. It's more like security in terms of like privacy of the user.
Got it, got it. I think we have a question. Is the salt same or different for all users?
Yes, yes, it must be different for all the users. And this is something that only the custodian and the individual user should know. So a flow that you can imagine is that the custodian is like sending to each user their own salt. And then whenever they are like generating the leaf hash, the leaf will be generated by username, salt balance, and then the user will be able to yeah, they will be able to regenerate this leaf hash.
Okay, right. We have another question from KPZM. For rain check, the circuit uses the same chip with n bytes for every sibling level. It only checks given siblings are under 2 to the power n bytes minus 1. Therefore, the sum of the sibling and the other node may cause overflow. Is this
Yes.
right?
Yeah, that's exactly the point of what we discussed before. So this is perfect question. This is like the what I was explaining before. So we only perform the rain checks on the inputs of the sum, not on the sum itself for efficiency reason. So given that we perform the rain check on the inputs, we can forecast whether it's a risk of overflow in the sum. So if you just scroll back in the chat, like in the example that I made before,
Mhm.
this is an example where you can perform a valid rain check on the inputs, but this can still lead to an overflow in the sum. And that's actually because of the combination of like the number of levels and the number of bytes. And this is what this assertion that we add in the verifier generator script.
Right. So to sum it up, we do a rain check on the individual balances, but we don't do a rain check on the sum of those balances because it could like lead to a lot of constraints and it could be done outside of the circuit. So we should like really come up with some cool solutions to this. Um, but yeah, this is definitely an issue. Coming back to the CSV thing, I think I had a hunch regarding um, maybe somehow creating a very big CSV or a huge CSV file to DDoS the whole protocol or something like that. Is it possible, Enrico?
To generate the CSV file. Mm, yes, we have a script because we also need this for testing, but
Mm-hmm.
mm, I think if you go inside benches, okay, no, it's not there. Probably it's not published like the script that we use. It's something that we use internally. So
Mm-hmm.
I will pass it to you, the script that
Okay.
we use, and you
Mm-hmm.
can use it for testing.
Right. And my final question is, how often is the proof generation to be done to, the proof generation process and the verification process would happen in an ideal world where the Summa solvency protocol is deployed when it's used by exchanges. Yeah.
Yeah, let me, I'm just writing down now. Mm. How often? Like okay, this is like a very ideal world, and it's probably, I don't know, 10 years the sure. But I see like a way that like this process is kind of something that is done automatically. So it's like every time you, I don't know, you load a HTTPS file, you know, there's
Mm-hmm.
like TLS certificate, and there's underneath there are like some signature certification, and your browser is automatically doing the whole work underneath. So it's not that every time you visit a website you manually check their TLS certificate. So ideally, this can should be done every minute, or at least like every time a user is visiting uh, a custodian, for example, or even a bank actually, and the your browser will be storing the information related to your balance, and every time you connect, there will probably be this kind of proof of solvency check performed automatically, and it will raise like a warning similar to when you visit a website that is telling you like this website is not secure, beware. Like
Mm-hmm.
this apply to proof of solvency. Like this is, of course, ideal world, but if you want a more practical answer, like the current exchanges are doing this. I think BitMEX is the one doing it more frequently, and is 2 weeks, every 2 weeks.
Oh, that's quite long. All right. Yeah, I
Yeah,
think
it's
we
quite
need like
long.
a lot of monitoring tools to monitor if the CSV generation is done properly, if the exchanges do hold the keys to all these accounts, and to like monitor the whole process of uh, uh, proof of solvency. I think that is like a need for this protocol. Yeah, go ahead,
Yes.
Enrico. Yeah.
Yeah, no, I just wanted to say that like so ideally what we want, what we aim for is that like many of these tooling are should not be developed by ourselves, and this is for two reasons. Like first of all, it's like we're like a small team and we cannot maintain like too many things, but it's also more kind of credibly neutral, I would say,
Mm-hmm.
if someone else building this tooling. So supporting like the checking the signatures, it shouldn't be a tooling built by Summa, but it would be better if it's a third party that is providing this tooling. So they're like kind of you distribute the trust across many parties, because maybe you don't trust the custodian, but what makes you trust Summa? So it's better if there's someone else and like many parties involved in this process.
Right. It's good if there's a joint effort by the ecosystem itself. So the whole process is like decentralized in a true way. All right. I think I've asked enough questions. I've got my doubts clarified. So if fellows have got more questions, you can obviously access the Suma General channel to ask your questions. And see you in the next session then. There's
Bye
nothing else. Thank you guys. Yeah, thank you, Enrico.
bye.